we're back with section 4.8, doing number 4. Now this is a little bit different because we're not using the same notation. We're given that little f, the second derivative of little f of x, is 12x squared plus 6x minus 4. And we're given two initial conditions. We know that f of 0 equals 4 and f prime of 1 is equal to 1. So these are initial conditions about the original function and the derivative. So if we're starting with f double prime of x as 12x squared plus 6x minus 4, we're going to find the antiderivative, which takes us to f prime of x. So if I go backwards through the process, the antiderivative, second derivative, goes back to the first derivative. And this is what I've done. I've used my power rule. So this would be 12x to the third over 3 plus 6x squared over 2 minus 4x plus a constant. Don't forget that plus c. It's so easy to forget. It's going to be important. Now, I'm not going to leave this as 12 thirds and 6 halves, so I simplified. And I got f prime of x, and keep your notation going. 12 divided by 3 is 4, so 4x to the third plus 3x squared minus 4x plus c. Now, remember that this information helps you find the constants. Those are your initial conditions. And I am going to find this constant by using, this is my derivative, so I have to use f prime of 1 is equal to 1, and that's what I did. I plugged in f prime of 1. So 4 times 1 cubed plus 3 times 1 squared minus 4 times 1 plus c equals 1. And I just did 4 plus 3. And I got 3 plus c, and c is equal to negative 2. I know you can solve for c in that. And because c is negative 2, that is what we put into our equation here for f prime of x. And that is a specific, I'm going to underline it here, that is a specific derivative. It has the value, negative 2 is our c. So notice I put in 4x cubed plus 3x squared minus 4x, and then I won't write plus negative 2, just write minus 2. Now, we're supposed to find f of x. So I'm going to find the antiderivative of this function, and the antiderivative will be f. And I'm going to use the power rule. Now remember, your power rule, I'm using this, is x to the n plus 1 over n plus 1 plus c. So in this case, I did, and write your notation. So your derivative goes down to a function, the antiderivative, so it becomes your original function. 4, I get x to the fourth over 4, and let's just multiply it here, and 3, and then x to the third over 3, minus 4x, this is a power of 1, so I just add 1 to that, x squared over 2, minus 2x plus c. And then simplify that, and you get x to the fourth plus x to the third minus 2x squared minus 2x plus c. And now to find c, initial conditions. So I'm going to use this one. So I know f of 0 is 4. So I'm going to plug in f of 0. And you see you get c is equal to 4. And your final answer, you're looking for the original function. And that function is, this is your answer. You're going to put, here it is, x to the fourth plus x to the third minus 2x squared minus 2x plus, and you just put that 4 in. Now if you want to make sure that everything's correct, this was your original second derivative, so let's take a look. What's the derivative of this? You can always check. It's 4x to the third, that's that, derivative of that, 3x squared minus 4x minus 2. So that is the derivative, and this one is 12x squared, yep, plus 6x minus 4. All right, we'll be back for number 5.